The James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth. The posts claim that the telescope captured the object changing its trajectory in an unnatural manner, meaning it must be some sort of extraterrestrial life.
Oh, nice. Yes, look at that bad boy.
This is a raw image.
It began quietly. Just another stream of data from the James Webb Space Telescope tracking a distant traveler called 3I Atlas passing through our solar system.
It's really a very anomalous object, perhaps natural, but we should allow for the possibility that it's something else.
But hidden in that flow was something no one expected. A glow too steady, precise, and too strong to come from ice or rock. As scientists probed deeper, the ordinary story of a passing comet began to unravel into something far stranger, something that seemed to shine by design. Could these lights be proof we're not alone? Stick with us to the end to find out. The first impossible glimmer. The James Webb Space Telescope was never meant to hunt for alien beacons. Yet in early July 2025, it caught something that looked like exactly that, an interstellar object, 3I Atlas, throwing off light in a way no natural rock or ice ever should. That first clean, unwavering glow stunned the team watching the data come in. It was too steady, too precise, the kind of signature that made even seasoned astronomers go silent as the realization set in. This wasn't a reflection. It looked like a signal. To understand why this mattered, you only need to know one thing. 3I Atlas is not from here. First spotted as a faint speck crossing the edge of the solar system, its hyperbolic path screamed of an object just passing through, the third known interstellar visitor after Oumuamua in 2017 and Borisov in 2019. Scientists were eager to study it for the usual reasons, to learn about the chemistry and building blocks of distant star systems. No one expected anything more than the faint, chaotic flicker of sunlight bouncing off ice and dust. That expectation was shattered the moment Webb focused its infrared eye on it. Instead of irregular scattered reflections, clean emissions that didn't waver with its spin or angle to the sun. There were no fuzzy halos from vaporizing ice, no random flares from tumbling debris. What the data showed looked organized, deliberate, and almost as if something on the surface was designed to shine. The timing made it worse. 3I Atlas was already speeding out of the solar system, giving researchers only a few months before it would fade into the dark between stars. Teams scrambled to coordinate every telescope available, desperate to capture as much data as possible before it slipped away. But the closer they looked, the less it resembled a wayward comet. The light it cast refused to behave like sunlight on rock. It moved as if something inside was switching it on. Patterns too perfect to be natural. The real shock wasn't that 3I Atlas glowed in the dark. It was that the glow followed a perfect repeating pulse, as if the light itself were obeying orders. Webb's instruments didn't catch the chaotic flicker of ice or rock. They recorded a precise sequence, grid-like rows sliding into view in rhythm with the object's spin. Natural explanations collapsed one by one, leaving only the unnerving sense that we were watching something engineered. Something that might not be natural at all. Natural objects don't pulse like that. Comets flare unpredictably as ices vaporize. Asteroids reflect sunlight unevenly as they spin. When analysts plotted the brightness from 3I Atlas, the curve rose and fell in precise intervals that matched the object's rotation, as if rows of light were sliding into view in sequence. Instead of a scattered shimmer, Webb's sensors caught neat, grid-like patches lighting up on the surface, structured, ordered, and too clean to be the work of erosion or random impacts. The deeper they dug, the stranger it looked. Computer models tested every natural explanation: reflective ice, unusual mineral sheens, odd angles to the sun. All of them failed. The glow didn't fade when sunlight should have been blocked. It stayed steady, as if it were being powered from within rather than reflected from without. That left a far more unsettling possibility. Something on 3I Atlas might be generating its own light. What made this even more compelling was the character of that light. Webb's near-infrared instruments picked up emissions in the same efficient wavelengths we use for modern artificial lighting, the kind you would get from engineered sources designed to minimize energy waste. The pattern was tight and consistent, not the diffuse signature expected from naturally glowing gases. For decades, the search for extraterrestrial intelligence focused on big, distant signals, radio beacons, or massive structures dimming stars. But this discovery felt closer, almost immediate, as if we had stumbled on the nightside glow of a settlement far from home. The lights weren't just visible. They behaved as though they were being switched on and off in a regular sequence, hinting at control or design. Every new set of readings reinforced the same point. These patterns were not random. Patterns were only the beginning. What the next round of scans revealed went beyond strange reflections. It hinted at something alive with power beneath the surface. If this unfolding mystery grips you the way it did those watching the data streams, tap the like button so more people see it. A dead rock shouldn't glow like this. When Webb's instruments probed deeper, they didn't just record reflected sunlight. They detected a steady heat signature rising from inside 3I Atlas itself. Something on that object was producing its own power, as if an engine or an energy grid was running beneath the surface. Objects drifting through space don't make their own light. They shine only because the sun hits them. But 3I Atlas is breaking that rule. Its glow is stronger than physics says it should be. It is so strong that astronomers are being forced to ask if something inside it is actually generating power. That meant the lights could not be explained by surface ice, dust reflections, or any passive phenomenon. To shine with that strength across tens of millions of kilometers, something had to be generating and directing energy, either by running powerful beacons or by lighting up wide surface zones. Teams tested every natural explanation they could think of: exotic radioactive decay, tidal friction, chemical reactions, and all of them failed. The evidence pointed back to one thing: an active power source. The first warning came from Hubble on July 18th, when the images confirmed the nucleus was only about 10 kilometers wide, too small to account for the excess brightness. For it to reflect that much light naturally, it would need a surface area far larger than what's been observed. That leaves only one explanation: an internal source of energy. This aligns with what Harvard astrophysicist Avi Loeb suggested, that 3I Atlas might not just reflect light at all, but generate it, possibly from a compact nuclear source. He even proposed it could be a long-traveled spacecraft with its strange dust trail, the debris it gathered across interstellar space. Loeb ruled out black holes, supernova fragments, and frictional heating as too weak to generate such a gigawatt of light. That left one unsettling possibility: the steady gigawatt-level glow might be powered by something built, not born. That changed the nature of the discussion. A glow powered from within suggests design, not accident. It implies that 3I Atlas was not just a wandering rock, but a constructed or modified object, and if someone went to the trouble of building or equipping it with energy systems, they likely had a reason to keep it lit, whether for navigation, communication, or perhaps to make sure it was noticed. Researchers could only speculate. Some thought the lights might serve as navigation aids, marking position or orientation. Others wondered if they kept an internal habitat warm against the deep cold, or even acted as a beacon aimed at civilizations like ours, knowing we now have instruments sensitive enough to detect it. Whatever the purpose, the point remained: the glow came from active, organized energy use. And just when scientists thought they had seen the worst of it, the object itself began to behave, erupting and going still again, as if following commands no comet should ever obey. The comet that defied the odds. The moment the full data package from Webb hit the ground servers, the tone in mission control changed. The strange glow on 3I Atlas had already raised eyebrows, but the raw spectral lines coming in now were worse. They looked engineered. Following a new series of tests and discoveries, this visitor showed that it doesn't play by the rules. Could it be the slightest sign of the talked-about alien invasion? Comets wander, flare, and fade according to the sun's pull, yet this one seemed to wait. When sunlight struck it, astronomers braced for the usual slow boil of gas and dust, the ice ball shedding its skin as it always does. Instead, it sat still, then suddenly erupted, as if it had been holding its breath. That first jolt came on the 22nd of July, when the Vera Rubin Observatory caught a thin haze around its core. But the real shock came a month later. On the 25th of August, the James Webb Telescope saw its gas density triple in a single night. No natural comet behaves that way. More eyes turned to it. Hubble's July images showed a pattern that made even veteran researchers uneasy. Instead of a smooth increase in dust, it spiked up one day, fell the next. Las Cumbres Observatory tied those swings to an oddly calm spin that happens 29 hours per rotation. A stable, even spin should spread heating and melting evenly, but the bursts came in precise fits and starts, as if timed. Some researchers blamed exotic ice trapped under the crust, bursting out when sunlight hit a crack. Others admitted the pattern felt too deliberate. The deeper telescopes probed the haze, the stranger it became. Instruments began to pick up unusual metals and odd chemical ratios, things no comet tail had ever shown. To many astronomers, it felt less like a frozen rock breaking apart and more like something responding, almost as if it were following an internal clock. And then came the Webb data, the pulse of ordered, grid-like lights shining across its surface. That single discovery pulled the erratic bursts into a new, unsettling frame. Perhaps the outgassing was not a quirk of nature at all, but part of a system, a sign of control, of something far more deliberate than ice cracking in the sun's heat. That sense of control deepened when researchers stripped away the noise in their data and heard something pulsing in the dark, steady as a heartbeat. The hidden pulse, a signal we weren't supposed to hear. The first time the pulse appeared in the data, it didn't look like much, just a faint, repeating spike buried under noise. But when the team pulled it out of the static, what they found didn't behave like any natural signal. It was too clean, too steady, like a mechanical heartbeat hiding in the glare of a distant star. Signal analysts at MIT and Harvard went over the readings again and again, running Fourier transforms to strip away the background hum of space. Each time, the same pattern emerged, a razor-precise rhythm nested in what had looked like random static. It repeated on the same interval, unbroken, as if locked to an internal clock. That regularity alone ruled out things like outgassing jets or dust clouds, which always flicker unpredictably. Next came the light itself. Webb's infrared sweeps had already shown narrow emission bands instead of the messy scatter expected from ice and rock. Cross-checking those bands with the pulse revealed that the glow rose and fell in sync with the rhythm. In other words, the thing wasn't just passively shining, something inside was regulating its output. More unsettling still, the frequencies themselves looked engineered. Some fell squarely into the same ranges we use for laser guidance and high-efficiency LED arrays. Others lined up with standard beacon bands that spacecraft on Earth employ to announce their presence. And as 3I Atlas drifted closer to the sun, the strength of the pulse shifted slightly, as if the source were adjusting power in response to changing solar input. Behavior you'd expect from an active system, not a frozen rock. Harvard's Avi Loeb noted that the data implied a self-sustaining energy source. A comet brightens when sunlight warms its surface and fades as it moves away. This object's emission held steady, defying that curve like it was running on its own power. Adding to the unease were the albedo readings. Certain patches of the surface reflected light as efficiently as polished metal. There was no comet-like tail, even as it neared the sun. No dusty outbursts from heating ice. Only that clean, persistent signal, wrapped in a surface that looked sealed tight, as if it was built to protect whatever sat beneath. By the time the teams compared all the data sets, the implications were unavoidable. The pulse wasn't an accident of nature. It behaved as if it were meant to be transmitted, possibly for an audience that was never us. We were just in the line of reception, overhearing a message that had been traveling across the void long before we were ready to notice it. Then, as if to confirm it wasn't just talking, it did something even more unthinkable. Its path through our solar system shifted, not with the push of sunlight or gas, but with purpose. If that signal surprised you as much as it did the analysts, share this with a friend who'd want to see the evidence. Trajectory shift. Proof. It's steering itself. In late tracking runs, 3I Atlas suddenly veered off its predicted course. The shift wasn't gradual, like you'd expect from solar wind or a comet venting gas. It was abrupt and precise, as if something onboard executed a controlled burn. Its stable rotation held steady during the maneuver, showing none of the wobble that natural objects display when they're nudged by outside forces. That single move upended every natural explanation and forced astronomers to ask the question no one wanted to voice. What kind of visitor adjusts its own path through our solar system? The first sign of this course correction came with a sharp spike in brightness detected by Webb, a jump of about 40% in just under 2 minutes. Natural heating from the sun couldn't explain it, nor could impacts or outgassing, because no debris cloud appeared and no tail formed. The flare was clean and sudden, and thermal readings shifted at the same moment, as if some internal system had powered up. Ground-based telescopes in Chile and Hawaii confirmed the spike. With no natural explanation left, the data suggested a deliberate reaction, possibly triggered by the sun's pull, or even by being observed. The idea that the glow itself might have been a response unsettled everyone following the feeds. Then came the trajectory models. NASA and ESA teams ran fresh calculations and saw a measurable deviation. 3I Atlas had altered its path to draw slightly closer to the ecliptic plane, the flat zone where most planets, including Earth, orbit the sun. Gravity alone couldn't account for it, and radiation pressure was far too weak. The numbers pointed to a powered adjustment, as if the object had changed lanes with intent. its rotation deepened the mystery. Instead of tumbling unpredictably, it kept a fixed orientation. That meant the light-emitting surfaces remained locked in place, behaving more like mounted panels on a spacecraft than the chaotic spin of a natural interstellar rock. Experts floated ideas like advanced ion drives or exotic solar sails, but none fit the clean, deliberate nature of the maneuvers. The more the data was compared, the less it looked like a drifting relic, and the more it resembled a craft, one capable of navigating with purpose. The illusion of a natural wanderer fell apart completely when its very skin betrayed it. What came next still shocks astronomers till date. Alien alloys, evidence. It was built, not born. The lights and the strange maneuvers were unsettling enough, but the real shock came when Webb and Hubble began analyzing the object's surface and found materials that should not exist in nature. Spectroscopic scans revealed something no ordinary comet or asteroid could ever show: highly reflective metals mixed with exotic compounds that don't appear anywhere in our solar system. Some of these substances don't even match the periodic table as we know it. They showed up in patterns that suggest they were engineered, not formed by natural cosmic processes like supernovae or frozen slush. The absorption lines in the data were especially alarming. They hinted at quantum-trapped materials, matter shaped under extreme magnetic confinement or particle compression, the kind of manufacturing that would require advanced technology far beyond ours. Nothing about it resembled the random mix of rock and ice typical of interstellar debris. As the object drew closer, Webb's higher resolution readings showed that its outer shell contained rare earth alloys and radiation-hardened composites. These were the kinds of substances we try to design for spacecraft to survive deep space, except these were far stronger, more efficient, and appeared to have been fabricated, not naturally formed. Teams at ESA and Caltech compared the data against every known geologic and astrophysical process. There were no matches. This wasn't the residue of a dead planet or the crust of a comet. It looked like the protective skin of a machine built to endure the extremes of interstellar travel, cosmic radiation, micrometeorite impacts, and eons of exposure. This discovery forced scientists to rethink everything about the object. A comet's surface erodes and fractures over time. This one looked pristine, as if built to last for millions of years. The combination of exotic materials and apparent self-fueling behavior painted a stark picture. This wasn't a wandering rock, but a durable interstellar device, built either by a civilization long gone or by one still active, and it had crossed the void to reach our neighborhood. But the revelation that sealed its place in history came when we dared to speak to it. The reply, when the watcher looked back. The moment no one expected came when we finally called out to it, and it answered. That single exchange shattered the idea that 3I Atlas was just a drifting relic. The delayed signal, faint yet precise, hinted at intent, as if something out there had not only heard us, but was choosing to respond. From that moment on, every telescope glitch and data dropout felt less like a coincidence and more like a quiet warning from the visitor itself. Even before that moment, fear was spreading behind closed doors. Internal NASA and ESA memos, some of which later leaked, debated whether 3I Atlas was a derelict relic or an active probe observing us. Defense agencies quietly treated it as a potential threat. Secure communications went into lockdown. Researchers were reassigned under classified orders. Ground stations worldwide were ordered to tighten security while still feeding data to the same central networks. The idea that it might not be alone, that it could be the forward scout of something bigger, kept creeping into reports. Its stable spin, controlled power output, and unusual materials all pointed to a machine built to survive the void for as long as it needed to. If it was reporting back, the obvious question was, to whom and how soon? While governments scrambled in private, one team at the SETI Institute took the risk others avoided. They transmitted a narrow, carefully encoded radio pulse toward 3I Atlas's projected path, math constants like pi and prime numbers, a simple periodic table, and even crude representations of human figures. It was a cautious but deliberate "we're here." For 3 days, there was nothing. Then, a single ground dish in Chile picked up an unusual narrow-band return signal. It wasn't random static or a simple echo. It came back with a deliberate 72-hour delay, the round-trip light travel time, and the pulse was shifted in frequency, as if the message had been received, processed, and sent back on purpose. That was the turning point. The reply was faint and distorted, but its timing was exact. Something on board 3I Atlas had heard us and responded. Almost immediately, other oddities began to appear. Webb's infrared cameras glitched when focusing on it. Hubble's pointing sensors showed unexplained micro-wobbles. Ground-based telescopes reported brief dropouts or scrambled frames when locked on target. These incidents happened too consistently to be dismissed as a coincidence. ESA analysts suggested deliberate interference, just enough to blur or block parts of our view, as if the object wanted to control what we could see. It had heard us, it had answered, and now it seemed to be choosing what we were allowed to witness, as though the watcher had turned its gaze on us. If something that old, that distant, can listen and reply, what else might be already listening in the dark? What do you think 3I Atlas really is? A relic from a lost civilization, or the scout of something that still waits beyond our stars? Tell us in the comments section below, and don't forget to subscribe so you don't miss what could be the biggest revelation of our time, because the next chapter of this story could change everything we know about our place in the universe. Thanks for watching. See you in the next one.